Dr. Harrison. I'm going to talk to you about problem 957. In this problem, we have an atomic nucleus moving with a speed v, colliding into a target particle of mass 2m. And we're told that this particle is scattered 90 degrees. 90 degrees. Okay? Now, when it's scattered 90 degrees, this particle is going to be scattered also. So what do we have to find? We don't know the final velocity of A, we don't know the final velocity of B, and we don't know this angle. So there are three unknowns. Okay, so what are we going to use? We're going to use over here the conservation momentum in X. In X, we have the velocity here, mass times velocity, that's before the collision, so that's mv. And after the collision, we have this particle over here. So it's going to be mass 2m, vb, cosine theta. So the first equation is mv equals 2m vb cosine theta. Now, what about in y? Before the collision, nothing's moving in y, so we have 0. After the collision, this is moving in y. But this one also has a component moving in negative y. So we have we have mva positive, and we have minus 2m vb sine theta negative. That's the second equation. But we have three unknowns. So we need three equations. Because this is a perfectly elastic collision, we have to use conservation of energy. Conservation of energy says the energy that we have to start with has to equal the energy that we finish here and the energy here. So it's 1/2 mv squared equals 1/2 mva squared plus 1/2 mvb squared. Right? Now, we want to simplify these equations. There's m's. We take out the m's in the first equation. We have v equals 2 vb cosine theta. That's this one. This one has a minus sign, so if we put this one on this side, we have va is going to equal 2 vb sine theta. That's this one. And here we have a half, get rid of those, the m's, get rid of those. So you have v squared equals va squared plus 2 vb squared. Now, v squared, we take this v and square it. So that's 2 becomes 4, vb squared cosine squared theta. And for VA, we square this. That's going to be 4 VB squared sine squared theta. And we have this 2 VB squared. So now, can we simplify? We have VB squared, VB squared, divide by that. You'll have 4 cosine squared theta equals 4 sine squared theta plus 2. We divide by 2, we have 2 cosine squared theta equals 2 sine squared theta plus 1. Okay? Now, what is 1? What is 1? A squared plus b squared equals c squared, sine squared plus cosine squared theta equals 1. It's a trigonometric identity. So now, can we combine the terms? Here we have 2 sine squared theta plus sine squared theta, 3 sine squared theta. Here we have 1 on this side and 2 on this side, so there's 1 on this side. So now, if we divide by cosine squared theta, we have 1 equals 3 sine squared theta over cosine squared theta. So 1 equals 3 tangent squared theta. Divide by 3, 1/3 equals tangent squared theta. And if we take the square root, that's the square root of 1 over the square root of 3. That's 1 over the square root of 3 is tangent theta. And now, if we make a triangle we say, what is the tangent of theta? It's a over b. And if it's 1 over the square root of 3, this is 1, this is the square root of 3. So a squared plus b squared is c squared. So 1 plus 3 is c squared. C squared is 4. C is 2. So 2. So the sine of theta would be 1 over 2, 0.5. So theta is equal to 30 degrees. 30 degrees. Now if theta is equal to 30 degrees, we solve for the first variable. Theta is 30 degrees. And now we go to find VB. V from this equation, V equals 2VB cosine theta. So VB is V divided by 2 cosine theta. So it's V divided by 2. The cosine of theta would be the square root of 3 over 2. And the 2's go out. So it's V over the square root of 3. And in the second equation, VA equals 2VB sine theta. So we have VA is 2VB sine theta. So VA is 2. This is V over the square root of 3. And the sine of theta is 1 over 2. 1 over 2. So the 2's go out. So VA is V over the square root of 3. So theta is 30 degrees. VB is V over the square root of 3. VA is V over the square root of 3. What about the fraction of kinetic energy that's transferred when this particle strikes this point? The kinetic energy is equal to 1/2 mv squared. That's the kinetic energy when you stop. So you can't have more energy than that. Okay? And that's going to be 1/2 mva squared plus 1/2 2mvb squared. Okay? So 1/2 mv squared is 1/2 m. VA is V over the square root of 3. Squared is V squared over 3. This is 1/2 2m. VB is V over the square root of 3. Squared is V squared over 3. When you factor out the 3's, then you have 1/2 mv squared equals 1/3 1/2 mv squared plus 2/3 1/2 mv squared. And so 2/3 of the kinetic energy is transferred to this particle, and 1/3 remains. Thank you very much.